In this video, I would like to take some data off of a website, in this case, a Wikipedia page on alkali metals, copy it over to Excel, and make an XY scatter graph, choose a variety of trend lines, see which one fits best, and also in there, transpose the data, a number of things. So let's get started. Okay, so here I'm open up to Wikipedia, alkali metals. Down on the page, there is this table. That's what I'm interested in. So I'm going to highlight the table, make sure I'm not above the table. I don't want this header. Make sure I'm not below the table. I don't want this sentence. I just want the table. So there's my highlighting the table, and I am right-clicking and choosing copy. And then I'm coming over to Excel, over say in here in A1, I'm going to right-click and choose paste. I have two paste options. And the first one says keep source formatting. And so you see these blue underline things. So over on Wikipedia, they had a bunch of hyperlinks to take us to other web pages. And Excel would do that. I don't want it to do that. That'll be a nuisance. So what other pasting options are there? This second one is match the destination formatting. So just take the data, make it more Excel-like, and that suits me better in this purpose. So I will choose that. Okay, so now I have the data brought over from a website. When you're pulling data from another source, it is, when Excel, we typically, what things we want to do in Excel are, and I want to plot some data, so I want to work with some numbers. Sometimes when you're pulling data from a table, Excel doesn't always recognize it as a number. It is recognizing these as a number, and my clue is that the numbers are right justified. So words like lithium and sodium are clearly text, and they are left justified. A number, sometimes there's like a little space or some other kind of symbol in there that makes Excel think that it's text rather than a number, but not in this case. In this case, these are numbers. I can have a pretty good guess that Excel recognizes them as a number because they are justified the way Excel justifies numbers, which is right justification. Okay, I wanted to plot the melting point versus the atomic number. And I prefer my data to be going down in columns rather than across in rows. So I'm going to do another copy paste, this one within Excel. So I'm going to highlight the data. Again, highlight the data, choose copy. And then again, pick a cell, in this case, I1, and then I'm going to right click again and choose their different pasting options. There's generic paste, there's paste values. If I had used any formulas, values would ignore the formulas and just give me the result of the formulas. Then there's a paste version for formulas, and then there's finally the one I want, which is the transpose option, which is to exchange rows and columns. So now I have the data in the format I want. The different atomic numbers are increasing as I go in one column, as I go down rows, and the same thing for the melting points. And I find that plotting that's the sort of natural order of data that you want to plot. So it's easier if it just matches what Excel is expecting. So I'm going to take this old data that I no longer want. It's the same data, but the other formatted data, and I want to get rid of it. So I'm highlighting, I'm going across dragging across the gray cells at the top. They're turning green, and I've highlighted entire columns, and I'm going to right click and delete. What I'll call my header row here. There are very long phrases in here, and you can't see most of it. So I'm going to highlight the gray one, the entire row, and right click on that and go to Format Cells, go to the Alignment tab, and choose to wrap the text. And so that allows the text to wrap, to take up more than one line. I can then get my double-headed arrow when I'm between cells 1 and 2 and drag, and I can control. So it will decide how much space it thinks it wants. And if I don't like it, then I can drag and control it myself. But if I want to go back to its cell controlling, I can get my double-headed arrow and double click, and it will decide. Okay, so I want to plot melting point versus atomic number. So melting point versus atomic number. Melting point is what I want on the y-axis. Atomic number is what I want on the x-axis. And in Excel, it likes the numbers that go on the x-axis to appear first. So they're in the right order, but there's stuff in between. So I have this C and D, these things in between the two, the B and the E, that I want to plot. So 3 approaches. I'm going to take eventually the third one, but two other options. One is I can just delete columns C and D. So if I just highlight those C and D and right click and delete, then the E and the B will be next to each other and I can proceed. Another possibility, since there's not too much data here, is to just make copies of it. So there's a copy of the atomic. Here's a copy of the melting point, and I can just use copy and paste to put them next to each other. So I can delete to get them next to each other. I can copy and paste to get them next to each other. Neither of those is what I want to do. I'm going to delete that. Instead, what I'm going to decide to do is just to highlight them as is, as non-consecutive columns. I need, one thing I need to point out is that the melting point for francium is a question mark. Francium, I think, is radioactive, short half-life, doesn't hang around long enough to figure out a melting point, so they're not reporting one. Okay, so what I have to be careful about when I highlight data from different columns is that I'm highlighting the same number of rows, the same rows and the same number of rows. And when the things are next to each other, well, that's kind of usually clear and obvious. When you're highlighting non-consecutive things, not so much. So I'm not going to highlight anything from row 7. So I'm not going to highlight the 87 because I don't want the question mark. The headers B1 and E1, I can highlight them, and I can also not highlight them. That it's sort of my choice. Sometimes, like, what Excel's really honest to God going to plot are the numbers. So you don't need the headers at all. It will throw the headers maybe into titles or axis labels or something. So it might do something that you want done with those headers. And I've seen it sometimes wreak havoc to highlight the headers. So if something goes wrong, you're trying to make a plot, you think you're doing everything right, but you've been highlighted the headers and it's going wrong, try it without the headers. It's always an option. Okay. I'm going to put in the headers. These headers are not so complicated that it's going to cause any problem. And so I'm going to start off by highlighting B1 to B6 by just dragging. So I just dragged my mouse, so put my mouse button down and held it. And I had this cursor, which it's the highlighting cursor. I usually refer to it, at least in Windows, Excel, I call it the fat cross. It's got this black outline, this white sort of fatter part, and then a black outline around it, and it's the shape of a cross, so I call it the fat cross. And I'm dragging from B1 to B6. And now I want to get E highlighted. And so now, and it's not consecutive, so now I hold down Control. So B was a normal drag. Now I'm going to hold down the Control key. While I'm holding down the Control key, I highlight E and a drag and make sure I get the same number of rows. And then I'm going to let go of the drag. And then I'm going to let go of Control. And now I have 2 things highlighted. I'm not holding down the mouse. I'm not holding down the control. If I try to make my graph as I hold down control, it's going to make a very bizarre graph. So make sure you let go of control. Finish the dragging of the second column, and finish that and let go of the dragging, then let go of control. Insert. Now I'm ready to make the graph. Insert. I'm going to choose XY scatter. It's easy in your early days of plotting to confuse line graphs and XY scatter graphs, but we want an XY scatter graph. I'm going to choose just the data. There are only a few data points, and also I want to add a trend line when I'm done. So the line is going to be a trend line, not this goofy sort of connected dot kind of stuff that Excel makes available. So I'm going to choose just the dots. If I have a lot more data, sometimes I will choose to connect it, but in this case, not. Okay, so that's my basic plot. When the chart is highlighted, there are options related to making the graph. So here is the graph is highlighted. You see here chart design and format. If I click away, they're not there. But so with the chart selected, I'm going to chart design, quick layout, and I like quick layout number 9. It gives me a lot of the features I want. It gave me an x-axis label. On my x-axis, I have the atomic number. Usually I like to have the units, but this is the atomic number. It's a number. It's the number of protons. There's sometimes people we have like atomic mass unit as the unit for something like this, but I'm just going to leave it. I'm just going to say it's a number and leave it as it is. And I can note that, you know, this axis, the range is going from like 0 to 60, not quite getting up to 60. And that is indeed the atomic number. So these are the atomic numbers. Over here was the melting points. And that did have a unit of degrees Celsius. And I usually put my units in parentheses, and I want a degree symbol. So I'm going to use insert on the top menu and go over to the far right over here, grab symbols, grab the symbol menu. And since I've done this before, degree was already highlighted, but degree is close to the letters. So it's near the top of this scrolling. So we see numbers, we see capital letters, we see small letters, and not too much after the small letters do we see the degree symbol. And I'm going to insert it, close that, type in my capital C, close my parenthesis. If you decided to forego the degree symbol there, sometimes there are these typing shortcuts of weird things. And I think if you try to put open parenthesis, C, close parenthesis, in certain circumstances, it might turn it into a copyright symbol. So one, I wanted to show you the degree symbol. Two, I didn't want to fall into that trap. So there we go. So I have my axis labels that I like right now. It gave me a title. I don't like this title. That's really not the title of the graph. That's more the y-axis label. And a lot of people say, write for their title, melting point versus atomic number. I don't find that. That's already sort of clear that that's what it's a graph of by my y-axis label and x-axis label. So there's no additional information in that title. So it's not an incorrect title, but it's just not doesn't provide anything more than what's already there. But the information that is more information is I'm going to say that this is alkali metals. Okay, so this is melting point versus atomic number for the alkali metals. That is additional information on the graph. Okay, what else? Also not giving us sort of additional information in this case is this legend. Sort of, it's telling us that the blue dots are the melting points. I label the axis melting point, and the dots by convention are the data. So that's not really helping me. And also the convention is that the line, in this case, a dotted line, is the fit. So I'm not finding anything. Again, it's not wrong to have this legend, but it's not doing anything for me in terms of giving the viewer of my graph any additional information that's not already there in the conventions. So I'm getting rid of it, delete. I'm going to drag this equation up out of the way. Okay. Now, so it gave me an X, and I edited the X-axis label. I edited the Y-axis label. I changed the title. I got rid of the legend. I moved the displayed equation. In addition to the displayed equation, the displayed fit equation, I also have the R² value, which is a measure of how good the fit is. And some people will use it like as a percentage. It's a variable between 0 and 1. And a lot of people will read it as like a percentage. 73% of the data is explained by this mathematical form. Okay, but we want to look at some other mathematical forms. So I'm going to right click here and format the trend line. It's going to give me other options other than a straight line. There are 4 of these lines. 4 of them have 2 fitting parameters. So a straight line has a slope and an intercept. That's 2 numbers. It gives you 2 fitting parameters to make the line come close to all the points. There are, of the options Excel gives you, exponential also has 2 parameters. Logarithm has 2 parameters. The power has 2 parameters. Polynomial has more, so it's sort of like it's not a fair level playing field. So I can make a polynomial fit really well, but and sometimes that's what we want to do. But in this case, I just want to compare the 4 things with 2 parameters and see which form fits best. There's this moving average thing. For me, the answer is never moving average. I think it might be occasionally useful in business. I don't find it useful to explain scientific data. Okay, but let's look at our other options. We're starting with linear. We want to see who's better. We'll be able to see sometimes by I, but we're also going to look at this R². It's better if it's closer to 1. So right now we're starting off with linear. It's 0.73. We go to exponential. That's 0.89. So that's clearly, it looks better, and the number was higher. Let's try logarithm. That's 97. That looks better and is higher. And then let's go to the 4th option and try power. So we're at 97, and that goes to 98. So that's better. This one doesn't necessarily look better, like logarithm and power. They both looked pretty good, and it was a small difference in the R². So if we had some reason to choose, some theoretical reason to choose logarithmic, then we would. But in this case right now, we're just playing with pure R²s, and it was close, but power was better. So we'll go with the power. So that's what we're picking, power. We had the 4 types with their 2 parameters, 2 fitting parameters, and we kept polynomial out of the competition because it wasn't fair, because it had more parameters. Moving average, I just don't like. And so power was the best. Okay. Close that. If I do this too early, I mess things up. But now that I have the form I like, then I can increase its font size. If I do that earlier, I update the line, but not the display, and then I'm not displaying my actual line. So that's a problem. So once I get the form I'm interested in, then I'll increase the font size of this equation. One last thing I want to do is I want to now use this equation to make a prediction. If I were going to sort of make my prediction, make my guess of what I think the melting point of francium should be, then the melting point is Y, and the X is the atomic number. And I know the atomic number of francium, that's 87. So I'm going to stick 87 in for X into my formula and get a prediction for the melting point of francium. So I'm just going down here, I'm going to type my 87 just to have a clean isolated 87. And then I'm going to enter my formula. I'm just going to like read the formula off the graph instead of doing anything fancier in Excel. So 396.72, and that gets multiplied by, when I display equation, the multiplication is implied, but in Excel, when you're entering formulas, the multiplication is always explicit. You always have to put in the asterisk. The X that I'm particularly interested in is the 87. So I go over and I highlight my cell with the 87 in it, which was B9 in this case. That gets raised to a power. So that is the caret in Excel. And then I'm going to put in the power is negative. So I'm putting it in parentheses. I don't need to, but I am putting it in parentheses. And then the power was minus 0.638. And I'm closing my parenthesis and entering my formula. And there is my predicted melting point for francium of 22.9. If I were thinking about that on the graph, then francium would be over here somewhere and at 87, and then this would be coming down. It's less than 50 and more than 0. So 22 or 23 sort of makes sense. So that's what I wanted to show you. This bringing the data over from a website, transposing the data, fitting it, trying different trend lines, a number of things.